Welcome back, and we're here for another section of Math 068, Professor Needing. This is going to be Section 5, Statkey Basics. We'll be starting on page 22 of our student workbook. And in this particular chapter, we're not going to do a lot of mathematics, but we're going to kind of make the connection between creating the graphs in Statkey and the data that we're utilizing. As always, please feel free and highly recommended to take a look at and read all of the things that are in the notation here. But these are all the things I'm talking about, so I'm not going to read them to you. First of all, to get to Statkey, Statkey is a completely free tool for you. You don't actually have to be signed up for this math class to get to it. And you'll always be able to get to it after you're done with this math class in case you ever need it for something. Most people don't remember the website right here, and it's really not that important, but you can utilize it if you want to. However, if you just simply go to your internet browser and you just type into your internet browser Statkey, and hit enter, Google will find it very quickly. It's called lock5stat.com. And if you click there, here's the picture of what we're looking at when we talk about our Statkey. Now, a couple things just about Statkey in general. One, we can get back to anywhere we want to the main screen, no matter where we are, by simply hitting the Statkey button up here at the top left-hand corner. There's an accompanying site up here, Statistics Unlocking the Power of Data. You will need to be able to go there and get data. When you're in the Math 168 course and you're running lab number 1, you will need to do that. And I have a nice video in the 168 course to help walk you through the beginning steps of that lab number 1. On the left-hand side over here is descriptive statistics. In the middle is bootstrap confidence interval level. Randomized hypothesis on the right, and then at the bottom we have not only sampling distributions but theoretical distributions. We won't do anything with the very bottom row right here, but we will work in the other 5 areas. But today we're going to be working in this one here. So I'm going to go back to your notes and do a little discussion, and then we'll jump back to Statkey. So first of all, same picture that we're looking at when we're talking about, and again, like I stated to you, clicking Statkey will take you back, and I'll show you how that works, but it's pretty straightforward. Now, in Math 168, we've already had the discussion about quantitative and categorical, 2 different types of data types. To confuse these 2 things would have an astronomical effect on you making your graphs and getting ultimately your answer or your data in Statkey. So we want to make sure that we clearly define the difference between quantitative and categorical. Quantitative is something you count. It's a test score. It's the number of miles per hour you're going. It's how many pounds something weighs. It's the stress factor on something. Categorical is simply a tick mark that says, I did that, or I'm in that group. So if we're talking about males, we would count the number of males. If we were talking about the number of people between the age of 40 and 45, then that's a tick mark. That's a categorical value. Male, female, whatever have you, freshman, sophomore. So when we talk categorical, we are in fact counting up numbers, but it's the number of people who are in that category. When we break it down a little bit further into our variables, there are 5 distinct areas we can have. And the first one is the one quantitative, or 1Q. We often refer to that as 1Q. One quantitative variable is simply a statistical measurement of something that has data values to it. If I were to take all of your test scores for this course only and put them in a piece of paper, that would be one quantitative variable. I'm not breaking you into groups and comparing you to somebody else. I'm just simply taking your numbers and I am measuring them. When we're talking about things that are one quantitative, a dot plot, a box plot, a histogram is our preferred choice of making a graph. And I'm going to jump to Statkey real fast. And I'm going to show you that if I chose one quantitative, you will notice that the 3 types of plots are dot plot, histogram, and box plot. So it goes along with what I just said. Secondly, the statistic for any one quantitative variable is going to be mean, X bar. We also talk standard deviation, and we also talk 5-number summary. These summary statistics, and that's a big one for you because we often ask you about the summary statistic for a one quantitative variable, is going to be X bar or standard deviation or a 5-number summary. I'm going to go back. So let's jump over to one categorical. So remember, one categorical is these check boxes, these male, female, how many people are in each particular category. Well, if we want to explore that and just decide what it is we should be using on there, we'll go back to Statkey. And remember, click the Statkey to get back. Choose one categorical, and you will see clearly that it's simply just a bar chart. There's no choices at the top for choosing a different graph. Bar chart. And the statistic, the summary statistic, is a proportion, p hat. Proportion, p hat, is the summary statistic for one categorical variable. The one quantitative and one categorical. Okay, so this is where I'm going to take something and break it into a group, but I'm also going to measure it quantitatively. Remember, the quantitative was the box plot, the histogram, and we could also sometimes throw in, a little mixture in there of the dot plot. So when we talk about this one quantitative categorical one, and if we jump over, watch what happens. Now, since we have a category involved, the minute we go one quantitative and one categorical, we still have the dot plot, the histogram, and the box plot, but they're side by side, we call that. We have one here and one here. We have one here and one here, and we have one here and one here, because those are the categories. On the left-hand side, you can see male, female. Over here, that's my category. And then these values down here are my quantitatives. The summary statistic is still the mean, but now it's a difference in the means. What is the difference between X bar of male and X bar of female? What's the difference between standard deviation of male and standard deviation of female? Difference of means, difference of standard deviations. All these will be important to you as you're answering questions coming up on your first examinations. Two categoricals. Okay, well, I already over here at a categorical said the only deal we had going on was the bar chart, and it was a proportion. So that stands to make sense that if it's two categorical, then in two categorical, it should be two of these. Well, we don't put them next to each other, as we'll see here in a second. We'll go back to Statkey. We'll grab two categoricals, and you'll notice right away that we have two bar charts, male and female. And inside of there, they are stacked for categories. So the first category is male, female. The next category is agree, disagree, don't know. This is a two categorical system. This is called a stacked bar chart for two categoricals, or 2C. The statistic that we would look at here. Now remember, these are proportions inside of these, so we would look at difference of proportions. Difference of proportions. This one just has a count table, and it doesn't actually have proportions listed. We would calculate those proportions, and we would take their difference. And the last one is a two quantitative variable. This is where I have two quantitative variables, one on the x-axis, one on the y-axis. This is where we saw where we're using a predictor and an equation to predict a response given an explanatory. So when I look at these two quantitative variables and I go to Statkey to check that out, see our last kind of chart, two quantitatives. You'll notice that it kind of looks like a dot plot, but remember, a dot plot was just on the x-axis. This is referred to as a scatter plot. A scatter plot is utilized in order to calculate two quantitatives, one on the x-axis and one on the y-axis. The statistic on this is a correlation, correlation, a correlation. And a correlation will be discussed more and more and more as we continue class. We do talk means because they're, again, quantitative values, and we do have standard deviations, but we don't take the differences. We find the correlation for them. 2Q is a correlation. Also, when you're in Statkey, this will be a very important thing to you, showing a regression line, and you'll want to make sure you know how to turn on the regression line. Notice that switching the variables changes the way the data looks. However, though, you'll notice the correlation remains exactly the same. again, that will be important to you, switching the variables, and that the correlation remains exactly the same. So that's a really nice overview of Statkey and where to look at things. Again, it shows you here that this is what we're studying in Statkey, and this is what we are studying in the class. So uploading data into Statkey and choosing stuff. So I'm going to show you how, and it doesn't matter which category we're in or what kind of data we're in, all of this will go exactly the same. Okay, so I'm going to show you how to edit the data and how to upload data at the same time. So let's go back to Statkey and let's go back to the original. And let's just say that we're working with, let's go one quantitative and one categorical. Okay. So on the left-hand side over here are student data, or excuse me, student surveys, TV by gender. If you do the drop down, there are a number of different things preloaded. Now, nothing says that your preload is the same as my preload, because I've done some other things and maybe you haven't done certain things and you may not see the same things. But by changing, let's say April 14 temps, I'm changing the actual data. Now, if I want to edit that data, I can click on edit, and like your book shows you, you can go in and you can physically change these numbers and you can make them different values if you want to. And I just changed that to a 75, and I just completely changed that data that was in there. I added 75 into here. I could see it in a histogram instead. I could see it in a box plot. Now, let's say that the data that you want is not in here. So you go to edit and you would have to change all of this data, or the book is telling you to go look at some other piece of data. Well, the way we do that is we go back to Statkey. We're going to go out to the textbook and we're going to go find some other data, because there's a lot of data on the textbook. I'm going to click there. I'm going to go down to the left side to where it says data sets. It's right above Statkey. Data set. All of these are data sets that we refer to in class. So let's just say that we're going to take the body fat one right here. Always take the CSV. Notice it's downloading the CSV file to my download area in the bottom left. Yours is going to go somewhere. Mine goes on the bottom bar. So that is in my download file as a CSV. We do not need to open it as a CSV. I'm going to go back over here and return to Statkey. Back at Statkey, I'm going to go into, again, one of these. I'm going to pick something, and I'm not quite sure what the data is I just chose, but we're going to try and choose one quantitative and one categorical. So again, when I click that value open, I'm going to go get the data set that I just uploaded to there. And it just decided to be like super slow to me for some reason. We're going to pick up the pace here in 1 second. I may have to stall a couple of things that are working in the background so that I can make this happen. Okay, so I paused my video and hopefully that's going to help me. So I'm going to go here to upload file because I want to go in and get that file that I chose. Remember, it was called body fat. I'm going to choose body fat. I'm going to open it. Now, the first thing it tells me to do is I have to choose a quantitative and I have to choose a categorical value here. So first of all, I have to go find something that's going to have that kind of thing. So it says choose quantitative first. So I'm going to choose body fat when I choose that. Now, it appears that I don't have a categorical because I don't see anything that's listed as categories. I have all quantitative. So the data I picked is quantitative. I'm going to switch my type of statistic. I'm going to go to quantitative, or I could have gone one quantitative. It really wouldn't have mattered, but I noticed it was quantitative data I chose when I did the expectation for you. Upload the file. I'm going to go grab it. I'm going to open it. And now I'm going to choose my X variable. Notice it says X first and Y second. So I'm going to base it on age, X. I'm going to base it on abdomen right there, Y. I'm going to say OK, and there's my data. You can see that age is on the bottom, and the abdominal is over here. And if I want a regression line, here it is. If I want to go back and I want to re-upload that for something different, maybe a single quantitative, then I can go back to my single quantitative. I can upload that same data piece, body fat. I can bring it back. I can choose maybe neck, say okay, and there's my quantitative variables. If I want to change a histogram or a box plot, then there it is. That is modifying your data. Same thing happens for categories. You can edit a category. Notice the category is at the top. So here's first one, response, and frequencies, how often it happened. So the response is the categorical, and the number of times it happened goes along with each of those. So 735 agree, 1812 disagree. The majority of the time, you will not be editing data like you see right here. The majority of the time, you will be uploading data like I just showed you. Pay attention to if the data has a header row, and this data does have a header row right here, response and frequency. The custom data set is what I just showed you for pulling in. Now, this is, again, an extension of what we just talked about at first. If you have one quantitative, I already told you, a dot plot, a histogram, and a box plot. And again, you will see those in Statkey. One categorical or one C, a bar chart, one quantitative and one categorical, one Q, one C. Now you're going to do side-by-side dot plot, histogram, and box plot. Notice they're the same as these dot plot histograms over here. If you have two categoricals, in two categoricals, you have a segmented bar chart. Segmented bar chart. I'm going to move that. And if you have two quantitatives, you always have a scatter plot. Scatter plot has an R correlation. A bar chart has a proportion. These all have a mean or X bar. These, again, have the same as these, a proportion. These, again, have the same as these, an X bar. The only difference in when you have two things is you're going to find the difference of them here. You're going to find the difference of them here. And over here, you have a correlation. Student exercise. Investigate which graphical display would be most appropriate for doing the work. This is an often asked style of question, just to let you know. Investigate in birth order, youngest, middle, oldest, and only child. So first of all, student exercise number 1, those are all categories. Remember, if you went back up top and you said, okay, I have a categorical, and in a categorical, I have a bar chart, it says it right here. Wish I could move that thing. Yeah, there we go. I have a bar chart. Well, that means that I should put that same bar chart down here. Bar chart. A little big. I got to make it small. It's not going to work for me. There we go. Number 2. Investigate the relationship between the distance, that's a Q value, measured in miles. Students live from main campus, and the weekly mileage, that's another Q value. So go up here. 2 Qs. 2Q scatter plot. So we're going to have a scatter plot design right here, and always with a 2Q situation. Keep clicking all over the place, don't I? Number 3, investigate the number of Facebook friends students in your class have. That's worded a little difficult, but let's say that this says we're going to investigate the number of Facebook friends that students have in your classes. So let's say we have multiple classes, and let's say we're asking friends how many Facebook friends they have. So that means we're going to have a category, which means the number of classes I have, and a quantitative value, which comes from the number of friends they have. So I'm going to go back up top. I have a quantitative and I have a categorical. It's going to be a side-by-side, one of these things. I go here, and this is the only one I have that's side-by-side, and it happens to me right there. When we talk about graph sets, these are the different graph sets, and we did a really good job of discussing these. So I think that under a quantitative, remember, a 1Q, it's always going to be a dot plot. Under a histogram will also work for a 1Q, and a box plot will also work for a 1Q. Neither one of them is the most appropriate. Here is the summary statistic. And this is, again, a huge deal for you to know that it will always be a value of the sample size, the mean, the standard deviation, and the 5-number summary when we are discussing. Remember, we're in quantitative right now. When we move to categorical, it's only a bar chart. There's nothing but a bar chart for 1C. In 1C, it's a frequency count and a proportion. This is the frequency count. This is the proportion. Always that way for 1C. If you mix a quantitative with a categorical, just did that a little bit ago. This is the same as having a dot plot, but now they're side-by-side dot plots. Side-by-side is the key because you have two things going on, quantitative, categorical. You could also use a histogram, side-by-side, and of course you could use a box plot side-by-side. The sample, or the summary statistic, is the sample size, the mean, the standard deviation, and the 5-number summary, and the majority of the time we're finding the difference of them. So we find one sample size and we subtract it from the other. We find one mean and we subtract it from the other. We find a standard deviation and we subtract it from the other. We'll need to know the difference in those topics. Two categoricals, it's only going to be a stacked bar chart, not a side-by-side, but a stacked bar. One category in each bar, and then multiple categories in each of those bars. They're called stacked bar charts. Their category is proportions again, and we find the difference of those proportions. So you can see here that we have a count table, which gives us how many. We could calculate the difference, but we also have a proportion table, and again, we could calculate the difference between. Not necessarily the total, but probably the difference. And when you're in Statkey, you can change between the row, the column, and the overall when you're on the proportion. Play with it, try it, you'll love it. Two quantitatives, 2Q, that's what we call it, 2Q, two quantitative values. This is always the scatter plot, not a dot plot, a scatter plot. And don't forget, there's a regression line here, and this value is always about the correlation. The correlation coefficient is the value which tells us what we have going on between 2Q. Correlation coefficient. And when you turn on the regression line, you get a nice little best fit line, which we'll be calculating in class. The summary statistic is a mean and a standard deviation, but you also have to add your word in there, correlation. Most often we call it a correlation coefficient. An R value when we talk about a sample, and that'll become more prevalent later. The 5-number summary is important because a 5-number summary can statistically be brought about, or excuse me, the 5 numbers that we come about. So we can have the sample size, we can have the correlation, the slope, the y-intercept, and of course the mean value. That's my 5 numbers. Here's the summary statistic, and the summary statistic shows all of them. And this is a shot from working in Statkey. This is your most important one right here, correlation. Slope will be important, and so will y-intercept, but correlation is your most effective or biggest time one going on. So the last part of this, student exercise number 4, you need to go back and listen to everything that we talked about, look at all the things we already wrote down and they copied into your notes, and find the most appropriate statistics, get all of them, and what graphical representation would you use for each of these. When we come back, we'll be into chapter 6, which is linear regression and relationships, and we will have more of a discussion about 2Qs when we get to those data values. Have a great time.